Hello everyone, today in this video we'll be discussing the third module of data mining, and in this module we have the main topic which is association analysis. Okay, association analysis. Then in the fourth module we have the classification. Okay, so we'll be discussing that later. First we'll discuss what is association analysis, and for understanding this module you need to know what is association. Okay, what is association? Association means closeness. If these two things are there and these two things are there, which is more closely associated? Obviously these two are more closely associated, so that's what we are trying to find out using some algorithms, which item sets are more closely related in a group of item sets. Means there are, like for example, 4 groups. In that, which group is more closely related with the items? Okay, that's what we are trying to find out. Okay, so the main things what you need to focus in this module are the association analysis, the problem definition, and it's means there are many definitions are there, like for different, like support count, what is minimum threshold, maximum threshold, and minimum confidence. Those things are there. Okay, so the definitions you need to know. By knowing the definitions first, then you will move on to the numericals. Okay, and the algorithm. There are two main algorithms in the numericals, which is the first is the frequent item set generation, and by this you will derive rule generation. So this is one part. The second part is FP growth algorithm. Okay, and in between whatever is there, it's not that important. I'll let you know what you have to focus and what you have to leave aside, so you'll be so that with the minimum time you can get maximum marks. Okay, so let me show you the questions what you need to focus upon. Okay, so in module 3, what are the questions you need to focus on? When you see the stars here, based on the stars you have to decide what things you have to focus. I told you, right, there are basic definition terminologies in association analysis. That's the first thing you need to keep in mind. Okay, after that, define association rule and explain support and confidence with suitable example. That's a greater detail of this one. Okay, the basic terminologies here is a greater detail for the two definitions among the many definitions. What is support and confidence with an example? Explain that. And what is association rule? What do you mean by association? You have to define in a more precise manner. Okay, that's important here. And the frequent item set generation, this is the algorithm what I told you. So what I need to focus in algorithm, explain the procedure of item set generation with example. Write the same in terms of algorithm, prepare for these problems in this concept. So problems can be asked, so you have to do it, apply the algorithm and find out the answer. Okay, and write the algorithm with an example and explain the same. And that was about the frequent item set generation, the first algorithm in this module. The second important one is FP growth. Okay, I'll come to that. Computational complexity of Apriori algorithm. So this is just about the drawbacks and what is the disadvantages of this algorithm. And rule generation means you will be having after using an algorithm, we will be having some rules. Based on the rules, you will be classifying what are the results to take, what are the results to discard. Okay, so that is known as rule generation. It's closely associated with this algorithm itself. Okay, so write the procedure for the rule generation. Same thing, whatever the algorithm is given to you, you have to write the algorithm for it, and as well as explain the using an example, and you should be ready to do the same for the if another set they give to you. Okay, these are the three things you have to keep in mind: algorithm, and the procedure explanation with an example, and the last one is numerical, you have to be ready to solve. Okay, so I'll be letting you know what I need to focus. So the last one is the FP growth algorithm. The same thing whatever I mentioned here, the same thing goes for this as well. The algorithm, the example, as well as the, if any new problem comes, you need to know how to solve it. Okay, and after these things they are just giving a brief information regarding what are the other methods for frequent item set generation. Okay, so two of the methods we discuss in depth, which is the frequent item set and FP growth. These are the two in depth we discuss in this module, and after that they give a few information regarding what is the other things, means other algorithms present that we can use for the same. Okay, so that are the topics, and I hope you got to know what you need to focus: the definitions and the frequent item algorithm and the FP growth algorithm and the problem. Okay, so that's all what you need to focus. So let's move on to the notes. So whatever notes I am referring, what are the question banks I am referring, everything is present in the link I have provided in the description box. You can find all the subject notes links there. You can go through it. Okay, and before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, it helps in making more videos like this. Okay, so let's get started with the module 3. So first, as I told you, you need to know what is association analysis. Association means what? Closeness. Just keep this one keyword in mind, that's enough for you. Okay, and for example, see here, there is a market basket. Here we have some items which are known as item sets. Okay, so this is the item set 1, item set 2, item set 3, item set 4, and item set 5. Here you can find out bread, milk, bread, diaper, beer, and eggs, milk, diaper, beer, and cola, beer, bread, milk, diaper, and beer, bread, milk, diaper, and cola. So when I was pronouncing these words at that time, you observe that some words are repeated more than others, right? So that's what we need to find out, which is the most frequent items repeated in the item sets. Okay, so how do we do that is that we will discuss later. This is just the a brief information. This is known as item set. Okay, and this is known as transaction ID. Okay, and what else do we have here? Okay, binary representation. So for each of these transactions I'll be marking down as ones and zeros. If it was present in that item set, it will be marked as 1. If it was not present, I'll mark as 0. Same goes for the other as well. That is known as binary representation. Okay, they can ask you for definition what is binary representation. You should be able to write this using an example and explain. Okay, what is item set? This is the item set, and it is 3 item set because 3 items are there. And what is support count? The frequency of occurrence of an item set. In the above table, the milk, diaper and beer, the items appear in for 2 times. Okay, so what is the support count means how many times these 3 appear in the different item sets. Means milk, bread and diaper. Where all do we find milk, bread and diaper? And so it's better to see the binary representation: bread, milk and diaper. Okay, so these 3 things, 1 1 1, where we find, here we find, and here we find. So among the 5 we find 2 times, so that's the support count. Support count is what? 2. Support count means how many times it has appeared by total number of transactions. So total number of transactions are 5, and how many times it has appeared is 2, so it is the 2 by 5. Okay, association rule means is an implication of expression x to y where x and y are disjoint intersects, and the strength can be measured in the terms of support and confidence. 2 things very important: support and confidence. If you remember in the question bank I showed you, support and confidence is very important question. Okay, so how do you find out the support, how do you find out the confidence? Okay, so consider the following example: milk and diaper goes to beer. Okay, so just consider this example here. Okay, this is x and this is y. So x is milk and diaper and y is beer. Okay, and support, and what is support? Fraction of transactions that contain both x and y. So both x and y means milk, diaper, beer. All these 3 things appear how many times? 2 times. And what are the total number of transactions? 5. So 0.4 is the support count. You understood, right? How to find out the support count. Next we move on to the confidence. Confidence means what? Measure of how often the items y appear in the transaction that contains x. How often y appears in the transaction that contains x. Okay, so firstly we'll be finding out the milk, diaper, beer, all the 3 together in the top, and the bottom, instead of just t, what we'll be finding out is this one, milk and diaper only. Okay, so it is more like x union y by x. Okay, it's like this is how we calculate the confidence. So milk and diaper just appears 3 times, so we'll be writing a 3 and we'll be having 2 here, so 0.67. Along with, see what we are actually trying to find out is milk, diaper is here, and along with beer, if we calculate how many times it has appeared with beer also, like milk, diaper is one team and beer is another team. Okay, and milk, diaper has appeared like 5 times. Now we have to calculate if beer also comes, how much times it appears. So if it appears still 5 times, then it's the best friend, right? If a beer comes and they don't appear at all, there's the worst enemies, right? So that's what we are trying to find out, if another happened to the existing data sets. Okay, that's all what we are trying to find out. And formulation of association rule in data mining. Okay, so what is the rule we are trying to find out? Support should be greater than some value, confidence should be greater than some value. If these two are greater than minimum values which we define, then it will be considered as frequent. Else if it is less than that value, it will be means not frequent. Okay, so here we have a value. So this is the bar which we have defined both for support and confidence. It can be different as well. So if the support count crosses this one but confidence was below only the answer, like for example 0.4 and this was 0.5 and the support we got 0.6, at that time only the support got success, but confidence failed, right? So it cannot be considered as frequent in terms of confidence, but frequent in terms of support it can be considered. Okay, and minimum threshold is this one, which is 0.5. Okay, that's what the minimum threshold is. And these are the basic terminologies. Explain it in your own words, give your own example. Okay, now we have 2 rules, 2 methods for generating it. Okay, so, yeah, fp growth and frequent item set. Frequent item set and fp growth. Okay, these are the 2 algorithms. Now in frequent item set we have 2 parts: frequent item set generation and rule generation. So frequent item set generation means we will apply some algorithms on a bigger data set, many items are there, and applying this algorithm, what it will fetch is fewer data sets. Okay, then what we'll do, we'll apply some rules to again classify this as whether it will pass the threshold or it will not pass the threshold. So first step, second step in the first part. Okay, so let's see what are the things we'll be doing here. Frequent attachment generation a priori algorithm. Observe carefully, listen carefully. This is very important algorithm. Okay, so I'll be taking an example and directly explaining the algorithm. And algorithm don't need to memorize. Write it in your own words. What all you understood. Okay, that's all what you have to do because many algorithms are there. Okay, let's get started. Here we have the transaction id items, so items are these ones. Okay, as you can see there are items here and the transaction ids are also given. Also we have been given with minimum support count as 3. Now I have to classify which will pass and which will not pass. So how do we do that is first write down all the unique items. What are the unique items you can find out here? Bread, milk, diaper, beer, eggs, yeah, and cola, right? I think these are the unique item sets which you can find out. So after you have written those things, then what you are supposed to write is what are the frequencies of that. Means how many times bread has appeared, count and tell me first. Bread, bread, and bread. So 4 times it has appeared, right? So you will write what, 4 here. Same thing you do for diaper, milk, beer, egg, and cola. After you have written this one, then what you have to check is if it is greater than minimum support count, pass it, otherwise delete it from the table itself. Okay, so how do you delete is just a scratch here like this. Okay, because egg and cola was appeared 1 and 2 times and it is 1 and 2 is less than what, 3. Minimum support is 3, it is less than that, so delete it. Okay, so you'll be considering this much only. If it is 3, you can take it in. Okay, that is the one item set generation. After you have generated one item set, you're supposed to generate 2 item set, then 3 item set, unless all the things will be deleted or something remains. Unless all the things will be deleted or something remains, you will keep on doing. I'll tell you what it is. See here, after you have done this one, what are the combinations you can form? Bread diaper, bread milk, bread beer, diaper milk, diaper beer, milk beer. These are the combinations you can form. And after you find out one combination, for example, if you find out like bread milk, then combinedly you have to find out where all, how many times it has appeared. Bread milk appeared here and bread milk appeared here, bread milk appeared here. How many times? 3 times. So what you are supposed to write here? 3. Same thing you do for bread diaper, bread beer, milk diaper, milk beer, and diaper beer. Okay, after you have done that one, cut all those which are less than 3. That is known as 2 items set, because 2 items set you are considering at a single instance, right? After that you consider those which are not less than 3. Okay, that will consider. After you have written that one, again make combinations of 3. Okay, like bread milk diaper together, then beer milk bread. Okay, like that you can find out, right, what are the combinations you can form. Write out 3 combination and find out which will appear more than 3 times. Okay, so as you can see there's none of the appearing more than 3 times. So what we'll do, we'll just stop it. Okay, we'll just stop it. So we'll write all item sets are infrequent because count is less than the minimum support count, like that we'll write. Okay, for example, if this was appeared 3 times, milk, bread, and a diaper, at that time what we will do, we'll consider that example, isn't it? Bread, milk, and diaper was appeared 3 times, so we'll consider, and that's the most frequent item set. But since it was 2, we'll not consider it. And after making this one, we cannot form 4 item set because only 3 are there. How can we form 4? We cannot, right? So we'll just consider this as the answer and we'll stop there itself. Okay, so algorithm also you need to write by yourself. Whatever you understood from this video, write it in your own words and move on to the next topic. Okay, so what is the next topic? This is another example, you can go through it if you want more information. And so these are the topics I'm just skipping now because there is no time to explain those things. I'm really running out of short of time, but these are not that important. Okay, so you can go through it if you want. Okay, so I'll be going directly to the rule generation. What is rule generation? Same things as we did in the previous problem. We'll be generating a frequent item set. After generating frequent item set from a bigger data set, what we will be doing, we'll be applying some rules for support and confidence and filtering out which will pass and which will not pass. Okay, so that is what this is what rule generation. Okay, so rule generation will do 2 things: support count and confidence count. Okay, so support and confidence will calculate. So these things we already discussed. The same things are present here. If it is greater than threshold, it will be a support pass and confidence pass as well. Okay, so I guess there is no, yeah, there is a problem here. Okay, fine, let's discuss that one. This is the important one. Okay, so solve problem for rule generation. Okay, the algorithm write by own. Okay, now we have the transaction details here, 1 2 3 4, and these are the item sets given to us. Now what we are supposed to do, first step, if you remember what I told you, how many unique are there, circle that, A, C, D, B, E, and write out how many times it has appeared in the problem. So in the one item set, this many times appeared, and remember what is the minimum support? 2, and minimum confidence is 70%. After you have done that, cut out all those which are less than 2. So cut out this, form 2 2 at a time and cut out which is less than 2, form 3 3 at a time and cut out which is less than 2. So we are just remain with BCE, and BCE is our frequent item set. Now we have to apply some rules. The rules are as follows. You have got how many letters? The B, C and E, right? So applying the rule generation procedure on obtaining the frequent items in BC, list all possible combinations. Okay, so BC goes to E, EC goes to B, BE goes to C. Okay, this interchange the rules. Okay, so here we will write E, means whatever you got here you will write here first, then you will write these things here. Okay, just do it in the reverse order. And totally 6 rules are. Now we should check for the confidence value for every individual rule. Okay, now we have to check for the confidence. What about the minimum support count? Okay, minimum support count is already passed here, right? Yeah, so this is the minimum support count is passed, and we got answer BC. Now we have to do for this one, it should be greater than 70%. So how do we do that is, see, observe carefully, we are considering the first one, BC goes to E. So BC goes to E, how we will write? BCE combined and just BC. How many times BCE combined has appeared and how many times just BC has appeared? So it will give 100% accepted. CEB, how many times CEB has appeared? Like numerator will be same for all. Okay, just denominator will differ. CE, how many times it has appeared? 2 times, and this also 2, 100% accepted. Third one, BCE, how many times it has appeared? Divided by BE, how many times it has appeared? 3 times, and here 2 times, so 66.6. It's less than 70, so it's rejected. Like that we will do for the remaining as well. Okay, so whatever passes passes, whatever fails fails. So passes will be these two, so that are the answers. Okay, so generated rules are BC goes to E and CE goes to B. These are the winners. Okay, so that was about the frequent items generation. The second algorithm is the FP growth algorithm. Here also I'll be doing the same thing. I'll be explaining the numerical what it is, and by that you have to write the algorithm in your own words and solve the other few other type of numericals in your own words. Okay, so how do we approach this? Is here also we're doing the same thing. We'll find out which is most frequent item set. So how do we do that? Is a bit slightly different approach. Okay, so let's discuss what is that different approach. So here what we have is 1 AB, 2 BCD, 3 AC. So these are the item set given, these are the transaction IDs given, and the minimum support is given what? 2. Now what we are supposed to do is we have to find out count all items in the whole transaction to get the count. Unique items, how many times it has appeared. After you have done this one, then what we are doing is arrange in descending order. Okay, descending order you have to arrange 7. It's already in descending order. Okay, so we'll leave it as such. If it was not in descending order, for example, it was like A was 2 and B was 4, at that time what will happen? The most frequent is C, then it is D, then it is B, then it is E, then it is A. Okay, that will be the order which we will be writing, but since it is already in the alphabetical order and the descending order as well, so we'll be leaving it as such, and we'll be proceeding further with the step number 4. So here what we have is, after you have written this one, what you have to do is you have to consider this one. Where is the table? Yeah, this is the table. This is a very important table you have to consider. After you have written that table, right, sorted table of each letter, then what you have to do is you have to start from here, AB. Okay, the first one is what? AB, right? So make a null node here. Okay, null node you have to make here. After that, AB you have to consider. Okay, the first transaction, AB you will write like this: A, then B. A one time only it has appeared, B also one time is only it has appeared as of now, because this is the first one, right? AB only one time appeared, write it as such. Next, what is this transaction? BCD. So BCD, how you will write? Start from here null, and you will see if it is C, you will see the previous one. You have to consider BCD, right? So you will see B is there in null node or not. It's not connected with null node, so you will make a new node as B, and then you will write a new node C and new node D, because the first time we are doing, it's not already present there. So you'll write there and write 1 1 1. So whenever you get same letter, make a dotted line to that letter. Okay, let's do the third one, which is ACDE. So what is that? ACDE, right? So we'll start from the null node and we'll see if it is connected with A or not. The first letter A, is it connected or not? It is connected, so I'll make it like this. Then I'll see if A is connected with C or not. It's not, so I'll make a new node as C, and I'll see D, no, E, no. So I'll make D and E. So after that, when one time it has appeared, so I'll write 1 1 1, but A, it appeared the second time. Through this only I am coming, the previous node. So A will be cut as and written as 2. So this diagram, it's given here. Okay, A has become 2, then C, D, E, and make the dotted line wherever you find the similar letters. Okay, then the fourth transaction is ADE. So we'll start from here and we'll see from the null node, is A, it is connected to A? Yes. Then is it connected to D? No. If it is not connected to D, make a new node D and then again E. So this will be the new node ADE, and A will become 3 because it's passing through the third time here. So like that we'll do for all the transactions, and when you reach the end, at that time you'll have a better, means you will have this one. This is the final one. Okay, after all the transactions. Now what is the minimum support count you have been given with? 2, right? So what you are supposed to do, just cut off all those branches which is less than 2. So what are the branches less than 2? Here we have this is not A, is 8, 2, less than 2 is this, not less than 2, this is less than 2. So I'll just mark which is less than 2, less than 2, and less than 2, less than 2, and less than 2, less than 2. After you have marked those, just cut off whatever branch it is connected with. So after you have cut off, this is the final answer. What you will obtain is A, B, C, and what is the other existing one? A, B, C, sorry, B, C. Okay, A, B, C and B, C is the final answer for this question. Okay, so that's how you'll be solving the FP growth algorithm. Okay, and advantages and importance, characteristics, and the algorithm ready to know nodes. Okay, and here are some methods for generating the frequent addition, some alternative methods. There are 3: general to specific, specific to general. These things we'll discuss in more detail in the next module. Okay, so just now for brief information, remember what it is: general to specific, specific to general. Okay, general to specific means, if I give you an example of PUBG. Okay, PUBG is what? PUBG is a shooting game, right? So PUBG is a shooting game. Okay, and shooting game comes in which category? Games. Games comes in which category? Entertainment. Entertainment comes in which category? Human emotions. That comes in which category? The psychology of humans. So this from general to specific, and this is specific to general. That's all. Okay, so same thing, characteristics. If you are going from general to specific, like this it will look like. If you are going from specific to general, it will start from a small point and it will move to the higher points. Okay, and equivalence classes, these are the prefix and postfix. Suffix equivalence classes you will form in the prefix way and the postfix way. So one will get at left and this one at right, so not that important. You can go through it if you want. Breadth first and depth first search. Breadth first, like this it will go, but depth first it will go first like this, then it will come back second, third, fourth. Okay, in 2 ways you can do the classifications. Okay, and evaluation of arithmetic association patterns. Okay, so what is evaluation? Association analysis of the potential general large number of patterns. You can easily end up with 1,000. Okay, see what happens is, you will generate patterns which will be many patterns, right? 1,000 patterns will be generated, but it will be very hard to classify all of those, so we'll filter it down. That is known as evaluation of association patterns. How to evaluate the results from the patterns we have obtained, because finally we need results, right? So how do we do that? That's explained here. So different type of association pattern evaluation are, means we'll calculate if what result we have got is it relevant or not. By using 4 factors we'll calculate: support confidence framework, interest factor, correlation analysis, and IS measure. These are all just has formulas, and by the name itself you can understand what it means. So just have a look at formula and write the definition in your own words. Okay, so I'll go through it each one by one. Support confidence framework: how much support and confidence is there by using the confusion matrix. And interest factors, this is the formula: what is the interest, how much it is closely related to each other. And correlation, how much it is closely correlated with each other. Is matrix, how much it is closely related with each other. Okay, like slight differences will be there in formula, but the basic the intention behind doing these things is same, just to evaluate is the item set which are generated are relevant or not. That's all is the main aim of this frameworks. Okay, so as you can see, that's all what is there in the module 3 of data mining, and thank you so much for watching. I'll see you in the next one.